Hello everyone, I'm going to do a quick tutorial on input shaping, a new Klipper feature that was implemented a few weeks ago. Now you may be wondering, why do I care about input shaping and what is it? Well, in the end, the important part is every 3D printer experiences some ringing in some form or fashion. Printers with moving beds, anything that has a large moving mass that needs to change directions quickly will have some oscillations. And as you increase the acceleration quicker and quicker, those oscillations will become greater and greater. So here's a great example. We'll get into it more in a little bit, but essentially this is a print where the acceleration was changed on my printer from 1250 millimeters per second squared all the way up to 6,000 millimeters per second squared. And you'll see that essentially as you get greater and greater, those ripple effects that are actually print artifacts get greater and greater. You'll notice there's one kind of point in the middle where it seems to be less apparent in this particular case, but for the purposes of this discussion, we'll consider they're all even. So what's cool here is that as you do these tests, this input shaper, and I'll zoom in just a little bit to get rid of some of the artifacting, but here's a test where there's very clear ripples, and this test is designed to accentuate them, but you see this ripple pattern is really bad. But when you go up here, this is after the input shaper has been tuned just a little bit, just a small amount of work. You see those ripples are largely eliminated, which is quite amazing. The first time I saw this, I actually went through and checked my printer settings again because I wasn't sure if it was actually true, if the acceleration had actually increased, because it was so significant. So essentially what it is as the printer is changing directions or changing velocities, just at a high level, it somehow changes the velocity input command to try to reduce the resonance that the printer experiences once it reaches a steady state. And I'm sure there's a ton of math and a lot of complex kind of logic behind this. I'd never heard of input shaping before, but a gentleman by the name of Dmitri, and I'm not going to try to pronounce his last name, but Dmitri has done a lot of work in the last few months or years on Klipper's SCurve. He's been doing a lot of development with that, and I'm sure a lot of you have heard of SCurve, which essentially tries to change the actual toolpath slightly in order to eliminate ringing or compensate for it. Input shaping isn't exactly SCurve. It is a slightly different thing, but input shaper has been merged into the main Klipper repo, which is a really big deal because that means you don't have to go through a lot of extra work to get it installed. It's still a little early. It's only been implemented a few weeks, so you will need to update Clipbridge to the latest version, which it's fairly, of course I went to the wrong thing. Yep, here we go. So if you have a fairly recent version of Klipper, you can just run these few commands here, or sorry, this one down here. Essentially just pulling all the new data from the Klipper repo. However, if you have an older Klipper installation, maybe you haven't touched it in a few months or a year, generally it's a good idea to flash your microcontroller too. So if you have a ramps board, a SKR, etc. So in that case, you'll have to follow these other steps for flashing the microcontroller. But once you have that, you can follow this tuning guide for ghosting compensation. And essentially what you do is you take this ringing tower, and I'll pull it up right now, which is in the test prints. Again, it's early on, not everything's gotten merged in, so you have to kind of hunt your way around a little bit. But this ringing tower is designed, it was the same print you saw earlier, it's designed to induce ringing artifacts in your print. And you'll notice this is the x-axis and y-axis, but actually the ringing on your x-axis shows up on after it's curved, gone around a sharp corner. So this is x-axis ring will be shown up here, and y-axis will be over here. And it's actually a really nice quick print too, because when you're doing print settings, generally a vase mode is great because you just want to have a single wall. And then for speed, you want to make sure that essentially your perimeters are at 100 millimeters a second, and that's really important to set those because you'll use that speed to calculate your ringing frequency essentially. And if that number is off, then your calculations aren't going to be correct. And then the other thing to note, I believe, let's see here. Of course, I should have checked this beforehand. One second here. Yes, here we go. Slow down if print layer time is below a certain number of seconds. Again, this is a quick print. So if you have a 15-second layer time, it's going to actually slow your printer down lower than the 100 millimeters a second we want. So I'm going to set this to 1 just to make sure that essentially the print's actually going at 100 millimeters a second. And then the last thing on layers, bottom layers, we don't need 5. That's what I typically do for prints, but we'll go down to 3 here in this case, just to make sure it adheres well to the plate. Then we'll slice that. And you'll see here 41-minute estimate. You see here that essentially it's just an external printer, just like base mode. I'm sure you've seen that before in 3D printing before. So you slice that, and then there's a few configuration settings you also need to do. In your printer config file, you want to make sure to change your acceleration to deceleration parameters to 7,000. So let's see if we can pull that up here just a second. Let's see here if I have a backup. Yeah, I do have a backup of my printer config. In your printer section here, see that I have max acceleration defined as 7,000, and then the acceleration to deceleration. This parameter typically doesn't get defined, and so you'll want to define it because if you don't, it ends up defaulting to half of your max accel parameter, and then you're not really getting the full value and the full test that you need. So you define those, and also you'll want to go down to your extruder section here, and you'll want to turn off your pressure advance. So in this case here, right here, I have it at 0.4. You'd want to change that to 0, essentially. So with pressure advance to 0 and 7,000, you do a firmware restart on your printer there, and then make sure after you press print, you send this tuning tower command. And this is really a cool thing about Klipper because you can play with a lot of parameters. In this case, it actually, as the print gets taller, it will change the parameter. So in this case, we are changing the acceleration factor from 1250 up to it's like 6,000 or 7,000 at the top. So you want to make sure that your printer can actually handle that, because I have a Core XY printer, I have a Voron printer, but there is, like for instance, a Prusa printer or an Ender 3. Those types of things can't hit 6,000. So you'll want to make sure that you're there while this print is being completed, so you don't break your printer. When you're done with the test in that 45 minutes, then here's where you start measuring your ringing frequency. And so I'm going to pull up that photo here again. So you'll see here in my case, you have these little patterns that repeat after these sharp transitions. And so you, again, exactly like the guide says, you want to measure between these different ones. And in this case, it wasn't super clear, but if we go to this one, you can kind of see these patterns kind of keep extending on indefinitely almost. They do dampen out eventually. But say you'd measure across, say, 1, 2, 3, 4, 5. So that's 4 spaces, so 1, 2, 3, 4. Then you measure from this point to this point. And then per the guide, you measure, or you calculate the ringing frequency as velocity, which was 100 millimeters a second, times n, that was 4 ripples, and then divided by d, which is the distance. So 100 times 4, so 400, and then say it was 4 millimeters long, you'd end up getting a certain frequency. In my case, I have a V1.8 Voron, 250 millimeter. I got around 35 hertz in both the X and Y directions. And so, you know, I'm going to do some more testing eventually to validate if that's correct or not. He actually has some other really cool work on putting an accelerometer on the tool head and then measuring your natural frequencies that way. But for the quick, test I did, I defined, and we'll go back to the config here, up here at the very top. There's a lot of parameters here, but really you don't need any of this for the cases we're doing here. So if you just define your shaper frequency for X and Y and put them here, and then again do a firmware restart and do the same print again. So take the exact same G code you sliced before, and then run this same tuning parameter again, and see the difference. And so in that case, again, this bottom image here is my first one without any input shaping, and then this second one was with those two frequencies. I think I had 35 and 35 during this print, but essentially this was the result. And I've done a lot of prints since then. Let's see here. Let's look at some cube photos here. Again, this is not the example of the perfect print, but on the right here is 7,000 acceleration without any input shaping. You see a lot of defined ringing here. It's just kind of ugly. And then over here, it almost looks like this wasn't printed at 7,000 printer acceleration. I've checked it over and over again. It's actually 7,000. Just looking at a different side, again, you get this ringing here around the perimeter, whereas here you can see a slight bit, but it's greatly reduced. And we'll just keep going around the cube here. Again, same story as before, just a lot of reduction there. So I'm really impressed with this, to the extent that this is almost a bigger deal for me than pressure advance. It's maybe an hour or two of testing, and a lot of that's just printer time, and these changes are dramatic. I'll have to keep testing it. Again, a Voron cube and a ringing test is one thing. So I tested some printer parts here. Again, this is maybe a typical print kind of quality settings, the acceleration that I typically have, that on outer perimeters it reduces the acceleration. Here is, again, that 7,000 acceleration with no input shaping, and then here is with the input shaping and still at 7,000 acceleration. And note that that is about over my default profile that also Doc at the Voron Discord uses a lot for his printed forward work. It's about a 10 to 15% reduction in print time. So that adds up, especially if you're doing prints on a daily basis. That's multiple hours there. Let's look at a different example. Again, at the bottom, which is the base profile, you do have some ringing, but it's not terrible. When you go up to 7,000, that gets fairly exaggerated. But then once you get to the top, that ringing, even this little section right here, is almost completely clean, which is amazing. So I am really impressed by this, and I'm really excited to see what your results are. Again, I may do another post once I get the accelerometer in. I'm just excited to see, this is just really cool that people are doing the work and helping out the community like this. So I think that's just about it. Again, if you want to know more about the different configuration parameters, there's different shapes, etc. In the example extras section of the Klipper main repo, again, check for resonance compensation, and you'll see kind of some more descriptions about each of the different parameters that you can adjust. And there's a wealth of knowledge that I'm sure the documentation will keep on getting better and better as more of his stuff gets merged in. So that's all. I just wanted to let you guys in on that and see what your results are. So thanks so much. Have a good one.